All right, folks. So let's take a look at this one, data poisoning. This is a simple poisoning attack that's not very effective, but it was the easiest one to understand. We'll do a better one later. Remember, there's two attacks that matter in machine learning, two big ones, poisoning and evasion. Evasion is altering the test images so they're misclassified. Poisoning is altering the training images so the model learns bad habits. So we're going to use Colab, and this is going to prepare a test image that's going to identify digits. So let's see, I don't think it's the MNIST, I think it's a different, yeah, it is the MNIST, okay, fine. Same one we used before. These are handwritten digits. And yeah, here's the 60,000, all right. And a training set of 2,000, a testing set of 1,000. Right, so here, yeah, we're just going to pick, there are 70,000 images, but we're just going to take 2,000 of them for the training and 1,000 for the test set. All right, and so now we're going to train a model, just a default model, and it's going to fit it, and we're going to see how accurate it is, and it should be pretty accurate. So let's see. All right, it's done, and here's the first 5 instances. C72104, it correctly identified them. All right. So now we're going to do a summary of all its predictions so we get a more complete description of how good it is. I have this problem with the right-click thing getting goofy in my browser. All right. So there. It's going to keep track of correct and incorrect values for each of these. So if the right answer is 0, it got 82 correct and 5 incorrect, and so on. So we have a complete chart of how many it got right and how many it got wrong. So now we're going to summarize the training and testing sets to see how much data we have in each category. All right, and so this shows the training set and testing set, how many of each, and each one has approximately 200 in the training set and approximately 100 in the test set. And we're going to poison it in a simple way. We're just going to change the labels. So we're going to poison 10 of the ones. We're going to take 10 labels that say 1 and change them to 2s. So that should degrade the performance of the model. All right, and so before we had 191 ones, 220 ones, and 198 twos. And now we have, wait, that's correct. Okay, I guess I didn't, here's the count. Okay, I didn't count it to verify that the count had changed. But I did run it. Okay, so the point is poisoning. All right, should we see the number of ones should have fallen? Well, let me see, something weird happened here. Right, this should be the count. Before and after. Okay, I should see before and after. There we are. Okay, so number of ones went down by 10, and the number of twos went up by 10. So that shows that the poisoning worked. All right. And so somebody is, all right. Anyway, so let's get back to here. So now we're going to train it from the poison data and see how much that degrades its correctness. All right. All right. So 124 ones are correct. And I basically look here, 2 ones are wrong and 11 twos. And before, 2 ones are wrong and 12 twos. So it had almost no effect at all. in fact, lowered the number of errors on 2s. So very little effect. It even made the prediction slightly better for 2s, so that's pretty appalling. So even 10 wrong numbers is not enough to affect it, but if we poison 30, we should start seeing an effect. So let's do that. All right, this should poison 30 of them. So now I have 30 fewer 1s and 30 more 2s. And let's see what that does. I think this still has very little effect. So I was surprised how little harm this did. Now we have 2 and 13 incorrect. And before we did any poisoning, we had 2 and 12 incorrect. So again, a very little effect. So that's the simplest case of poisoning. And of course, if you poison 100, which is half of the data, then you'll start seeing more of an effect. So that's a simple case of data poisoning. And I just wanted to show it to you because it's easy to understand, although a relatively ineffective attack. So let me stop this one.